As a skateboard rolls down a ramp, a transfer of energy occurs. There are three types of energy we will be discussing. Mechanical energy is related to the motion and position of an object. Every moving object has mechanical energy. There are two forms of mechanical energy: potential energy and kinetic energy. Potential energy is stored energy based on an object's position. The amount of potential energy an object has depends on the mass of the object, the gravitational force of the environment, and the height of the object. Potential energy equals mass times gravitational force times height of the object. As a skateboard rolls down a ramp, its potential energy decreases as its height decreases. Kinetic energy is the energy of motion. All moving things have kinetic energy. The amount of kinetic energy an object has depends on the mass and velocity of the object. Kinetic energy equals 1/2 mass times velocity squared. As a skateboard rolls down a ramp, its kinetic energy increases since its velocity increases. The law of conservation of energy states that energy cannot be created or destroyed. That means as energy levels change, they are being converted or transferred into different types of energy. As a skateboard rolls down a ramp, its potential energy converts to kinetic energy. Mechanical energy is equal to the sum of potential energy and kinetic energy, assuming there is no friction or air resistance or other non-conservative forces. When a skateboard rolls down a ramp and its potential energy is converted to kinetic energy, its mechanical energy remains constant. Since we are assuming there is no friction, there is no loss of mechanical energy. Friction would convert mechanical energy into thermal energy known as heat. Downhill skiing is a classic illustration of the conversion or transfer of energy. In this animation, Ke represents the skier's kinetic energy, Pe shows the amount of potential energy possessed by the skier, W represents work done by an external force, friction, and Tme represents the total mechanical energy of the skier. At the top of the hill, the skier possesses a large quantity of potential energy, the energy of position. When starting from rest, the mechanical energy of the skier is entirely in the form of potential energy. Since she is not moving, she possesses no kinetic energy, the energy of motion. As the skier begins the descent down the hill, potential energy is lost and kinetic energy is gained. Notice the kinetic energy increases and potential energy decreases at the same rate as the skier goes down the hill. As the skier loses height and therefore loses potential energy, she gains speed and therefore gains kinetic energy. The amount of total mechanical energy remains constant during the skier's descent, indicating the conservation of total mechanical energy. Since there is minimal to no air resistance or friction on the descent, all of the skier's potential energy is converted to kinetic energy. Once the skier reaches the bottom of the hill, her potential energy is depleted and her kinetic energy is at its maximum. This energy state is maintained until the skier reaches a section of unpacked snow and skids to a stop due to the force of friction. The friction force does work upon the skier in order to decrease her total mechanical energy. The negative value of work indicates that it serves to remove energy from the skier. As the friction force acts over an increasing distance, the quantity of work increases and the total mechanical energy of the skier is depleted. It is converted into thermal energy, otherwise known as heat.